We can also use the KMap reduction technique for Boolean functions with 4 variables. So here is a picture of what the 4-variable KMap is going to look like. Now remember, if you have 4 inputs to a function, you have 2 to the 4 or 16 different input combinations. So that's why we have a 16-cell KMap. And here again, the indices are aligned so that every adjacent cell has a unit distance difference between the adjacent cells. So our number ordering here goes 0, 1, 2, 3, 4, 5, 6, 7, then jump down to the last row, 8, 9, 10, 11, 12, 13, 14, 15. And you need to consider what is adjacent to a certain cell. Well, it's anything to the right, left, up, or down of it. So 0 is adjacent to 1, 4, 2, and 8. So you need to think of this KMap as sort of wrapping around to the right and the left and up and down. Okay, so how do we use a 4-variable KMap? Well, here I've listed an empty truth table showing the index of all the different input combinations from 0 to 15 and 4 different input variables, which I've named A, B, C, and D. So I'm going to come up with an arbitrary function f, which will be a result of these 4 input combinations, and then I will enter it into the KMap and reduce the function. Okay, so we're going to first do a reduced SOP form. And remember, when we're doing SOP, we're looking at circling ones in the KMap. Okay, so let's suppose this is our function. I'm just going to arbitrarily put in 0s and 1s in this table and then see where that leads me. Alright, so let's suppose this is our function and we want to create a reduced SOP form of the function. So what we need to do is enter the function f into the 4-variable KMap, and we do that by the index. So the 0 index has a 0, 1 has a 0, 2 has a 1, 3 has a 1, 4 has a 1, 5 has a 1, 6 has a 0, 7 has a 1, 8 has a 0, 9 has a 1, 10 has a 1, 11 has a 0, 12 has a 1, and all these have 1s. Okay, so remember, when we start circling in KMaps, we want to circle the largest group of 1s possible, but we still need to be able to cover all of the 1s. So let's start with this group of 1s here. I see I can fit this one in this group of 4. So I'll go ahead and circle those 4 1s. I've covered those 4 1s. Now let's pick another color. Now these 2 1s I can circle in another group of 4. I can put it in this group of 4. Now even though these 2 have already been covered, I'm going to use them to help me create a larger group, because having a larger group will be more reduction. Okay, let's get another color. We have these ones that I have to cover. These can go in a group of 2. Now if this was a 1, I could have put it in a group of 4, because then these 2 and these 2 would be in a group of 4, but that's not, so this can only be in a group of 2. Alright, let's look at another. This one still needs to be covered. Now this one I have a choice. I could put this one in the group with this one with it, or I could put it with this 12 position. I'm just going to go ahead and put it in this group of 1. Oh, actually, I don't have to do that. I'm going to Control Z that. The better thing to do is, since I can put this one with this other one that hasn't been grouped, that would reduce the number of groups that I need and also cover these 2 1s in a group of 2. So that's the better choice. Alright, I still have this one to cover. So that one I'm going to cover in this group of 2, because that's the only adjacent one that it has. Alright, so now we can go ahead and write the equation. So we're going to say f equals So this black one, you can see that it's not going to have the A variable because it covers both the A naught and A sections. It's going to have B because you see it's in this B section. So we'll definitely have B. And it's going to definitely have C naught because you see it's in both the C naught sections. And doesn't have D because it goes over the D naught and the D naught section. So you see it has to be, you figure out what letters to use based on what's common within the group. Alright, now we're going to change to blue. The blue one is going to be, see if you could figure this out before I do. It's going to be BD. And then we have an orange. Orange is going to be, that's going to be A, no B's, C, D naught. Okay, let's do a green one. The green one's going to be A, C naught D. And we've got our pink one, which is going to be A naught, B naught, C. So there you go. We have now created the reduced sum of products form of this Karnaugh map. Alright, so guess what? We can also do a reduced POS form using Karnaugh maps. And just like when we looked at zeros in the truth table to get a regular POS form, to get a reduced POS form, we're going to look for zeros in the KMap. So I'm going to go ahead and go to the next page here. And I'm going to arbitrarily put in some values into the KMap, and then we'll see how we can put it into reduced POS form. Okay, so let's suppose this was the function we were representing and we want to put it into reduced POS form. So what are you going to do? You're going to circle the zeros, write equation for F naught, and then apply, what is it? De Morgan's law. Alright. Gotta love my handwriting. So let's start by circling the zeros. Now this is my favorite zero to circle. Now this zero, is it adjacent to any other zeros? Yes, it's adjacent to this one and this one. So if you can think about this as wrapping around in both directions, these four zeros are actually in a single group. So we can put them into one grouping of four. I like to show that because that's one that people sometimes don't see. Alright, this zero can go with this zero. This zero at the number 5 position looks like he can't be grouped with anyone else. So he's going to be all on his lonesome. And this other zero, we can group it with the one next to it. Great, so let's write our equation for F naught. Let's start with the blue grouping. The blue grouping is going to be what? 2 letters. Well, it is in the D naught and the B naught rows or columns. So B naught, D naught. Alright, let's do our orange one. Our orange one is just one, so it's going to have all 4 variables in it. It's going to be A naught, B, C naught, D. This is also the number 5 if you think about it. 0, 1, 0, 1 is 5, which is index 5. Okay, and we're going to do the pink one. The pink one's going to be A naught, B naught, C. And the green one is going to be A, B naught, and C naught. Alright, so we have our equation for F naught. To get it into POS, we're going to take De Morgan's, so we complement both sides. That black bar should go on top. Let me try drawing that again. Take the complement of the whole thing, so that's going to give us F equals B or D, and, oops, it's a dot and A, or B naught, or C, or D naught, and A or B or C naught, and A naught or B or C. Look at that. So there you go, 4-variable reduced POS form.